Hello everyone and welcome back to Math 127 Pre-Calculus 2. So in our previous lesson, we worked extensively with points in the rectangular coordinate system using the x and y coordinates. So in this section, we are going to explore a different way of locating points called the polar coordinate system. So instead of using the horizontal and vertical distances, we are going to describe points using distance and an angle. Okay, so let's go ahead and start. So these are, at the end of the lesson, we should be able to plot the points in the polar coordinate system, find the multiple sets of polar coordinates for a given point, and then convert those points to from polar to rectangular, and then rectangular to polar, and then also converting equation from rectangular to polar, and then vice versa, polar to rectangular. Okay, all right. So once again, a point is in the polar coordinate system is written in the form of r comma angle theta. Okay, so in this case, and then enclosed with parentheses. So r would represent the directed distance from the pole to the given point. And then the angle theta here represent the angle measured from the polar axis. Okay? All right. So remember from the previous lesson, we also went over about the positive and then the negative angle. So positive angle are measured if, for example, the rotation is counterclockwise. The negative angle measured if the angle is, again, if it is a clockwise direction. So when plotting points, well, you have to pay attention also to whether the value of r is positive or negative. So a negative radius, okay, so a negative radius, that means to say that you are, moving in the opposite direction of the angle. So for example, if you are going on that direction, you are going to opposite direction. Okay, and then of course, if it is positive, so as it is, we will just be counting that, the number of units on the radius. Okay, so now let's go ahead and begin. Okay, the following. Okay, begin plotting point such as the 3 and then 315 degrees. Once again, we know that 3 here represent the radius, and then 315 here degrees represent the angle theta. Okay, so once again, as we work through these three examples here, notice how negative values of r affect the location of the point. So a common mistake is plotting the point directly along the given angle without considering the sign of r. Okay, all right. So beginning with, both of them are positive, so that means to say that we are rotating it, okay, counterclockwise from the polar axis. And then since we do have a positive 3 here, so we are going to plot the point going out 3 units on the terminal side. Okay, so let me go ahead and start that. So this is our polar axis. Okay, and then rotating it counterclockwise, that would mean that would be located in quadrant 4. So we now have here a 315 degrees, okay? So after rotating that from this terminal side here, I'm just gonna go ahead and plot the point 3 units from this point, okay? So we'll have here 1, 2, 3, okay? So there you go. This is now the 3 and then 315 degrees, okay? So from the pole going to that point. Okay, so now we have there the 315 degrees. Okay, so now let's move on with the next example. Okay, so for the next example, still we do have here an angle that is a positive, so therefore we are also rotating counterclockwise. But then again, because r here is a negative sign, then we are going to plot the point going out 2 units along the ray opposite the terminal side of angle theta. Okay? All right, so if that's the case, let me just go ahead with the polar axis. Polar axis. And then again, we have here angle theta. So it's on here. Okay. All right, now, instead of counting along with the terminal side here, since it is negative, then therefore I'm going to count backwards. Okay, in opposite direction. So that's going to be 1, 2. So this is now the -2 and then angle pi. Okay, the angle that measures pi. All right, so as you can see here, instead of counting it along with that terminal side, I counted it opposite direction because r is negative. Okay, now moving on to the -1 and then the negative pi over 2. Okay, so this time, since the angle theta here is a negative sign, it's a negative angle, so we are going to draw that negative pi over 2 or rotate it clockwise, okay, from the polar axis. And because once again r is a negative sign, therefore we are going to plot the point going out 1 unit along the ray opposite the terminal side. Okay, so if we have here again the polar axis, and then we do have negative pi over 2. So negative pi over 2, that would be clockwise direction. Okay, there you go. Okay, so since now, so from this point right here, or what we call the pole, okay, so I'm going to count, instead of counting it along with the terminal side, I'm going to count backwards, okay, so by 1 unit. So we'll have here this point. Okay, so therefore this is now -1, negative pi over 2. Okay, so these are the location of those 3 given polar coordinates. Okay, all right, now moving on to the next one. Okay, all right, so again, unlike with the rectangular coordinates, so a single point can have many polar coordinate representations. So for example, we add or subtract multiples of 2 pi from an angle theta, and then we can actually change the sign of r and add angle the measures, which is the angle pi, for example, to the angle. So this means different ordered pairs can represent exactly the same location of the point. Okay, so given here, for instance, we have the point. Okay, so let's go ahead and plot the point at the right, okay, here in the polar coordinates, and then find the other polar coordinates of 5, and then angle with the angle theta, which is pi over 4, and then of the point for which given this condition. Okay, so first I'm going to plot this point. So we have here the polar axis, and then it's pi over 4, so counterclockwise. Okay, and so this is +5, so therefore I'm going to count, okay, along with the terminal side by 5 units. So we'll have here 1, 2, 3, 4, 5, since it's positive. Okay, so now this is let me just write a direction there for the pi over 4. So now we have here 5 and then pi over 4. Okay, all right, so that would now be the point. Okay, the given point, which is 5 and then pi over 4. Okay, so now let's go ahead with the first example. We want, in this case, we want r be a positive value, okay, and it must be, the angle must be between 2 pi and then 4 pi. So in this case, as you can see, the given here is 5 and then pi over 4. Obviously here 5 is okay because 5 anyway is a positive value. Okay, so let me just go ahead and write that. So 5. Okay, but then again, pi over 4 is not within this interval. So we want to make this given value within this interval. So what are we going to do? So what we're going to do, for us not to change the location here, what we will do is to rotate one total revolution. And we all know that one total revolution is 2 pi. So I'm just going to go ahead and add one full rotation. Okay, so I'm just going to go ahead and change that 2 pi into 8 pi over 4 to match that denominator here. Okay, so let me just use 8 pi over 4 instead of just 2 pi. Okay, so 8 pi over 4 is the same thing as 2 pi. Okay, so now simplifying this, we have 5, and then we have 1 plus 8. We have there 9 pi over 4. Okay, let's go ahead and check if this would satisfy the given condition here. So we have here r must be positive, correct? And then we have here that the angle theta must be between 2 and then 4. If I'm going to divide 9 divided by 4, I know this is between 2 and then 4. So this one is correct. Okay, so as you can see here, we have here a 9 pi over 4 and then 5. So same location. All right, now moving on to the next example. The next condition here is we want to have r, which is a negative sign. And then the value for the angle must be 0 to 2 pi. Okay, so once again, we want r negative, and the angle must be between 0 to 2 pi. So what we're going to do is to locate the point opposite to this direction. Okay, so we want to make it in this opposite direction. So in this case, if that point, okay, I'm just gonna go use another pen here. If this point, so for example, located on this side right here, what would now be the angle of this point? Okay, because we know that we want to have an angle from 0 to 2 pi. So what would now be this angle? Okay, so let me just go ahead and write this as a negative 5. Okay, and then what I'm going to do is I am going to from pi over 4 there, as you can see here, oops, this is not okay. Okay, so as you can see here, well, this is the angle that we're looking for, but again, we know that there's a pi over 4 here, but if you will see, it's like rotating it with a half revolution. So that means to say that from that given pi over 4, I am going to add half revolution, which is again 4 pi over 4, which is the same thing as just pi. Okay, I'm just matching the denominator from the first term. So we now have here negative 5 and then 5 pi over 4. Okay, so you can check. So we have here 5 pi over 4. And then instead of counting it on this direction, of course, since this is negative, we're counting it backwards, okay, on this direction. So again, we have exactly the same location. All right. Okay, let's go ahead with the last condition here. So for the last condition here, we want r to be positive, and then the angle theta here must be between the negative 2 pi and then 0. Okay, so what are we going to do? Okay, so 5 here is already okay. So now we'll have here 5. And then we just want to make that pi over 4 be a negative sign, okay? So what are we going to do? So instead of going counterclockwise here, so what we're going to do is to go clockwise. Okay, so it's like adding a negative total revolution. Okay, so that's going to be pi over 4. And then minus that one full revolution, but in opposite direction. So that's going to be 8 pi over 4. Okay, so that's going to be now 5. And then we have a negative 7 pi over 4. So as you can see here, it's now within that condition, which is the negative 7 pi over 4. Okay, so that's everything it for this example. Okay. All right, so now let's go ahead. Okay. Let's now connect polar coordinates to the rectangular system. Okay, so what we're going to use here is we're going to use that x is equal to r cosine theta. If you will notice here, we are just using the definition of cosine. Okay, that cosine is x over r. Okay, so I'll be using that. I'll be what do you call this? Isolating the x on this side. So x is equal to r cosine theta. And for y, this would be y is equal to r sine theta. Okay, and so also we are going to use this Pythagorean formula. So in this case, we have here x squared plus y squared is equal to r squared. And same thing, we are going to use that tangent theta, which is equal to the y over x. Okay, so once again, this formula actually allows us to convert a point from a polar form to a rectangular form. So as we solve examples, be sure your calculator is in the correct angle mode. Okay, if we're gonna use those calculators. All right, okay, let me go on this section now. Okay, so find the coordinates of the point with the following polar coordinates. Okay, so we'll start with the 3 and then the theta. Okay, so we know that the value for 3 here is the r. Okay, and then the value for pi here would be the angle theta. Okay, so we know that from the fact that x is equal to that r cosine angle theta. Okay, and then also we know that y is equal to r sine theta. So all I need to do is to substitute this value, these two values here in these two formulas. Okay, so now we have here that 3 cosine pi. Okay, so up to this point, we know that if it is a cosine pi, that is in, there you go, cosine pi, that's gonna be the x value, which is a negative 1, 0 there. So therefore, this is now 3 times the negative 1, which is equal to negative 3. Okay, now for the r sine theta, so this is gonna be 3, and then sine theta is equal to, as you can see here, we do have 3 times, and the y value here is 0. So therefore, this would now be 0. Okay, so therefore, the conversion of 3 pi here, the rectangular coordinate now is negative 3 and then 0. Okay, actually, if you're going to visualize this, they do have exactly the same location, whether you are using those polar coordinates or the rectangular coordinate. Let me just show you the first one. The next one, I'm no longer showing this, just to help you visualize where this is located. So if we have, as you can see here, if you have the 3 and then the pi, so polar axis, right? And then this angle over here. And then we're just gonna count 3 units along with the terminal side. So this is the point of 3 and then pi. And then if you're going to locate this rectangular coordinates, as you can see, negative 3 over here and then 0. Yeah, okay, so negative 3 and then 0 as well. Okay, so this is now the equivalent. So as you can see, these two information should have exactly the same location on the plane. All right, okay, so next one, let's move on with letter B. Okay, so given here you have the negative 10 and then pi over 6. We know that this would be the value for r, and then this would be the value of angle theta. Okay, so same thing, I am going to use this formula in order for me to convert those polar coordinates into rectangular coordinates. So for x is, again, r cosine theta. For y is equal to r sine theta. So we have here r is a negative 10 cosine pi over 6. We have here the negative 10 sine pi over 6. We know that on the plane, okay, so we have here initial side and then the terminal side. Okay, so if I'm going to draw a right triangle here, given that angle pi over 6, okay, so we know that opposite here, this is y is equal to 1, adjacent to pi over 6 is x is equal to radical 3, given that the radius here or the hypotenuse would be 2, okay. So now, if we are to evaluate this once again, we do have the given value, so negative 10 times cosine pi over 6 is radical 3 over 2, adjacent over hypotenuse. So there you go. We now have here a negative 5 radical 3. Okay, next moving on to the y. So now we have, oops, I did box that, not yet that final answer. Okay, so next we have here negative 10. And then sine, that would be opposite over hypotenuse. So that's going to be 1 over 2. So that's going to be negative 5. Okay, so let me write this in a coordinate, rectangular coordinate. So that's going to be x is negative 5 radical 3. And then for the y is negative 5. Okay, so there you go. That is the equivalent coordinate into rectangular coordinate. Okay. All right, now moving on to the next item here. Okay, we are on the point conversion from rectangular to polar coordinates. Okay. Okay. All right, so next we'll go on to the other direction here. So in this case, we are going to use the r is equal to that radical x squared plus y squared, and the tangent, which is tangent theta, which is equal to y over x, to find the polar coordinates of a given point, given its rectangular coordinates. So remember that the inverse tangent only gives a reference angle. We have learned that from section 5.5. Even though you are using a calculator, remember the inverse tangent only gives you a reference angle. So you'll still need to determine the correct quadrant before finding the angle theta. Okay? All right, so in this case, so let's say for example, we have find the polar coordinates of the point whose rectangular coordinates are 1 and then negative radical 3. Okay, so therefore we have here 1 and then negative radical 3, so somewhere over here. Oops. Okay, this point, 1 and then negative radical 3. Negative radical 3. Okay, let me just go ahead and check that. Okay, there you go. All right, so next one here. So what I'm going to do here is to find, okay, so this is now our, oops. Okay. All right, there you go. Okay. All right, so now let's go ahead and find the value for r. Okay, using this formula. So we have r is equal to, we know that this is x, this is y, so therefore this is 1 squared plus the negative radical 3 squared. Okay, so this is now equal to 1 and then plus 3, which is now equal to radical 4. So r is equal to 2. Okay. All right, so now moving on to, we will have now the tangent, okay? So like I mentioned, I'm going to use the inverse of tangent. So I'll just be writing it as angle theta and then inverse, okay? And then of y over x. So we have here y negative 3 over x, okay? Which is simply, of course, a negative radical 3. Okay, all right, so now let's go ahead and evaluate that. So that angle theta, we know that in this case, we know that this is of course that is the y, this is the x. So we say that this is the y value here is equal to negative radical 3. And so the x value here is 1. So therefore, the reference angle here that is again, that has again adjacent 1 and then opposite is negative radical 3. This would be the pi over 3. Okay? All right, from the, again, the special right triangle, okay? So we know that the reference angle there is pi over 3. But like I mentioned, we are not looking for that angle, okay? That angle is a reference angle. We will just be using that reference angle in order for us to find the angle that we're looking for, okay? Which is the angle theta here. Okay, all right, so therefore we will be using the concept of reference angle. So that's going to be the denominator here is 3, so I'm just going to go ahead and use 6 pi over 3 to represent one total revolution, which is 2 pi, and then minus the reference angle pi over 3, so that gives you 5 pi over 3. Okay, there you go. So it's 5 pi over 3. Okay, so let me go ahead and write this in a polar coordinate. So I'll start with the r followed by the angle theta, 5 pi over 3. Okay, so there you go. Okay, all right, so now, well, I think this is the last portion. Okay, not yet. Okay. Okay. All right. Now, yeah, this is the last concept. Okay. So we'll finish by converting equation from rectangular to polar and then polar to rectangular. So the substitution that you'll use most often would be the x is equal to, let me write that down here, or is it here? Yeah. So we have here the common equation that we are going to use. Okay, for whenever we're talking about angle, we can use this tangent theta, which is also angle theta here, which is the inverse tangent of y over x. Okay, and also this one, you can also use those, you can play along with those formulas. Okay, all right, let me go ahead and start with this one. Okay. All right, so for example, if we have, let's convert the rectangular equation to polar equation that expresses r in terms of angle theta. So we have 3x minus y. So first thing, so we have here, again, our goal here is to get rid of the x and then the y. Let me just go ahead and zoom that in. The x and then the y, okay? So we want to write this equation in a way that the variable there would be r and the angle theta, or the angle theta, okay? So we know that, okay, so from this case, we know that from the 3x minus y, we can actually replace directly the value for x and then the value for y based from the formula that I have shown you, okay? So remember, the value or the formula for x is, let me replace that x. We know that x is equal to r cosine theta minus, and we know that the equivalent value for y is r times the sine theta. Once again, I just copied these two values here from the formula that I just recently showed you. Okay, so next one, we can just remove those parentheses. Okay. Okay, I'm just gonna go ahead and follow what the expectation here. So we are expected to express r in terms of theta. So that means to say that we want to isolate r on one side of the equation, and then the rest should be written on the other side, expressing it in terms of angle theta. Okay, so therefore I am going to factor out the r. Okay, so I have 3 cosine theta minus sine theta equals 6, and then now I will be dividing both sides by 3 cosine theta. Okay, and so now we have here r is equal to 6 over 3 cosine theta minus sine theta. So you can see, I have now expresses the r in terms of angle theta. Okay, so final answer. Okay, so now let me go ahead and move on with the next item here. We do have here that b is equal to, sorry, that b is equal to, but letter b is x squared plus the y plus 1 squared is equal to 1. All right, okay, so what I'm going to do is once again express those x and y variable into their definition. Okay, so we know that we have here that x squared is the same thing as the r cosine theta, then squared, and then plus again y is, we know it's r sine theta plus 1 squared is equal to 1. Now as you can see here, I just changed the x with the r cosine theta. I just replace this y into r sine theta. Okay, so now let's just go ahead and isolate the r. Okay, let me square this. So squaring this first term here, that gives us r squared cosine squared theta. Okay, plus I am going to do multiplying this by itself, okay, or the FOIL method. So we will have here r squared sine squared theta, and then plus 2r sine theta plus 1 equals 1. Okay, all right, remember I just did multiplication here. So r sine theta plus 1 times r sine theta plus 1. You remember from the algebra, r sine theta plus 1. So I just multiply that, you know, using the FOIL. Okay, so I have this. Okay, all right, so now I am now going to, well, I can subtract both sides by 1 here. So now I will just have r squared cosine squared theta. Okay. Okay, all right, so next one here, I am going to factor out the r squared. Okay, so as you can see, I'm going to factor this out, but again focusing in the first two terms. Okay, and see what's my plan here and the reason why I'm factoring out that r squared. Okay, now you can now see, okay, a statement that has something equivalent based on our previous identities that we went over. Oops, let me just go, there you go. Okay, we know that under the Pythagorean identity that cosine squared theta plus sine squared theta is just simply equal to 1. Okay, so I can just replace that. So r squared times 1 plus 2r sine theta equals 1. Okay, so now we only have that r squared plus 2r sine theta is equal to, oops, this is 0, 0. Okay, so now I will be factoring out the common factor, which is r. So that's gonna be r, and then r plus 2 sine theta is equal to 0. Okay, now zero product property. So now we are going to separate these two factors with 0. So now we'll have r is equal to 0, and then the other one here is r plus 2 sine theta is equal to 0. Okay, so this one is okay. So now this one, which should be r is equal to negative 2 sine theta. Okay, so there you go. We now have here a statement that gives you a value for r in terms of theta. Of course, this one is 0, so that's okay. So we have there two statements for this given equation. Okay, all right, so now moving on to the next items here. Okay, All right, so now let's go ahead and convert polar equation now this time to a rectangular equation, okay? In x and y. So therefore, we want to convert everything here with in terms of x and y in the equation, okay? No need to isolate anything here, okay? It doesn't mention here. So our goal is just to make this statement, for example, the variable must be either x or y. Okay, so starting with r is equal to 4, okay? Again, I am just gonna go ahead and maximize all these values, equations here in order for me to convert this statement into rectangular. Now, I see here this statement that looks applicable in that given equation, okay? But the problem here is that r here is r squared. So what we can do here is to make r an r squared, so by squaring both sides. So now we have r squared is equal to 16. So with this, I can now replace r squared with the x squared plus y squared. Okay, so now I have x squared plus y squared is equal to 16. Okay, all right, so there you go, it's done. So we have now a rectangular equation, which is x squared plus y squared is equal to 16 from the polar equation, which is r is equal to 4. If you are going to if you are going to graph this, we all know that x squared plus y squared is equal to 16 is an equation of a circle, okay? Remember that 16 here represent the radius of the circle, and specifically we are referring with a unit circle, okay? And not unit circle, but the circle that the center is at the origin, because obviously we have your h and k, which is at 0, 0. Okay, so therefore this is the center, right? So we'll have there, okay, I'm not gonna point that. So we have there r squared here, which is the radius. That means to say square root of 16, we have 4. Okay, 1, 2, 3, 4. So this would now be the circle. Okay, which also represent the equation, which is r is equal to 4. That means to say no matter what angle you have, r is always equal to 4. Okay, 4 units. Okay, now moving on to the next example, which is the angle theta, which is equal to 3 pi over 4. Okay, now for this angle 3 pi over 4, if you're talking about angle theta, you can actually use this formula right here, okay, to convert that into a rectangular equation. Okay, so going back here, so angle theta is equal to 3 pi over 4. Okay, so like I mentioned, I'm just going to go ahead and use that angle theta is equal to inverse tangent of 3, so y over x. Okay, so let me replace this angle theta here into tangent, inverse tangent. So inverse tangent of y over x, which is equal to 3 pi over 4. Okay, all right, so next one. Okay, so now we do have here the inverse of tangent, which is y is a y over x. Okay, so in this case we can say that, okay, we can say, let me rearrange now. I'm just going to go ahead and remove the inverse tangent. So this is now y over x is equal to tangent, now 3 pi over 4. Okay, the common way of writing this, you all know that we always start with the trig function equals to that output y over x. Okay, all right, so there you go. We now have here that tangent 3 pi over 4 is equal to y over x. Okay, so next one is to evaluate the tangent 3 pi over 4. Okay, so we know that under 3 pi over 4, this is just simply equal to 1. Okay, so, but let me just go ahead and show it to you. Okay, so we have it here. 3 pi over 4, 1, 2, 3. So it's in here. Okay, 3 pi over 4. And we know that if you're going to make it, whoops, what is that? Okay, if you're going to make a right triangle here, special right triangle, okay, so 3 pi over 4, the reference angle here is pi over 4. Okay, subtracting 3 pi over 4 from half revolution, 4 pi over 4. Okay, so we know that these two sides right here are radical 2 and then negative radical 2 here. Okay, so there you go. So we have there the negative radical 2 and then radical 2. So in this case, we have here that we have y over x. Okay, which gives you that y over x. Okay, so now we have a negative 1 is equal to y over x. Okay, I'll just go to, I'm just going to make a cross multiplication here. So now we have that y is equal to negative x. Okay, so there you go. So this is now the rectangular equations coming from the angle theta, which is equal to 3 pi over 4. Okay, so let me go ahead and graph this. We know that when you are going to graph, this is like y is equal to negative x. So if x is, for example, 1, of course, the value for y is negative 1. So it's like an identity function, but it is decreasing. Okay, it's a straight line. Okay, so that would be our y is equal to negative x. So you can see here, if this is negative 1 for x, that is positive 1 for y. If negative 2 for x, then that is positive 2 for y. Okay, and also if you're going to look at that negative pi, as you can see here, that pi, which is equal to, angle theta is equal to 3 pi over 4, which is this actually. Yeah, okay, all right. Okay, all right, now moving on to letter C. Okay, now for letter C, we are going to convert r is equal to negative 2 secant theta. Okay, we do not have formula directly that I have given you for secant theta. However, we can use the previous identities that we have in order for us to convert secant in such a way that it would be just simply sine or cosine. And we know that secant is the reciprocal of cosine. Okay, so let me just go ahead and change that value. Oops, what's happening? So we have here r is equal to negative 2 over cosine theta. Okay, it becomes now the reciprocal, which is the cosine. That is why I have written it in the denominator. Okay, so now I'm just going to go ahead and cross multiply that. So this would now be r cosine theta is equal to negative 2. Okay, all right, and then after that, we can now replace that cosine theta into the value for we will be replacing it either x or y, and we know that r cosine theta is equivalent to simply x according to the formula. Oops. Okay. All right, there you go. We have here the x is equal to negative 2. Okay, so now this would now be actually the rectangular equation. Okay, since the equation is now expressed with the x or the y variable. Okay, so if we are to graph this, we know that this would be on a vertical line because it's x equals negative 2. 1, 2. So this would be a vertical line. Oops. Let me. Okay, which is x is equal to negative 2. Okay. All right, so there you go. So that would now be our equation. I mean the graph for the x is equal to -2, or this is the graph of r is equal to -2 secant theta. Okay. All right, now moving on with letter D. If you are now getting the process, you can now go ahead and try this one out and see if you can work on. So before going over with actually, this is the last example that we have. All right, so now let's go ahead and convert, okay, for this section. Now we have here r is equal to 10 sine theta, okay? In this case, again, we want to express this r and then that angles theta into just simply x and then y. Okay, so what I'm going to do here is to, again, you can actually multiply both sides by r. So multiplying this, we'll now have r squared is equal to 10. Okay. R 10 sine theta. Okay. Or we can rewrite that as r squared is equal to, so you will see exactly what I meant. Okay. So there you go. We know that we now have here r squared is equal to 10r times sine theta. Okay. So next, we now convert this into x or y. Okay, so we see here that this value right here, okay, we can see that it would be the value for y. Okay, all right, so next one, we know that the r squared here has its equivalent expression, which is the x squared plus the y squared equals 10y. Okay, all right, okay, so there you go. Actually, we're done, but let me go ahead and rewrite this in a way that it will be written in a standard form in a rectangular equation. Okay, so we all know that if you're gonna review the concepts under the algebra, we know that if you do have those quadratic term and then their coefficient are exactly equal, then therefore most likely this is an equation that represent a circle. Okay, so let me just go ahead and write everything on this side and make it a standard form of a circle. Okay, so it would also help me to graph this given equation. So that's gonna be x squared plus the y squared minus 10y is equal to 0. Okay, so this is now x squared plus, okay, so I'm gonna make this a perfect square trinomial so I can factor this a binomial. So I'm just gonna go use to find the third term here to make it a perfect square trinomial. We will just be using the formula b over 2 and then square. So b there is the -10. I'll just write 10 anyway. It will turn into positive. Okay, so that's gonna be equal to 25, right? So 10 divided by 2 is 5. Square of 5 is 25. So I'm just gonna go ahead and add 25 here, and to balance this equation, of course, I need to add 25 on the other side. Okay, so now I can now factor this with a square of binomial. So this is now y minus and then 5 and then square is equal to 25. Okay, so this is now the standard form of the equation. As you can see here, that the center of the circle here is at 0 and then 5. Oops. Okay, the center of the circle is at 0 and then 5. And then, of course, the radius here of the circle is at the square root of 25 is 5. Okay? All right, so now let me go ahead and draw that circle. Okay, I'm just gonna go treat that this is by 2. Okay, so I'll have 1, 2, 3, 4, 5. Okay, that's the center of the circle. So I'm just gonna go ahead and count 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, and so this is now the circle. Okay, all right, so there you go. So this would now be the graph of this given equation, the polar equation, and then at the same time, of course, the rectangular equation. All right. Okay, so now, as usual, now it's your turn to again do it on your own. Okay, so in this case, remember that you have to focus on finding equivalent polar coordinates and then convert points between coordinate system, and then also converting equation between rectangular and polar forms. Okay, so again, in this lesson, remember that you were introduced about the polar coordinate system, and then learn how to plot points and then convert coordinates and translate equation between polar and rectangular forms. So these skills will be important as we continue studying alternative ways of representing mathematical relationships. Okay? All right, so thank you for watching, and I'll see you in the next lesson.